All right, let's continue on with some similar pH problems. In this case, we're talking about things involving concentrations. So once again, I really want to organize my problem. I need concentration of H plus ions. Again, I'm going to write it in the notation I'm normally used to seeing it in the equation, which is bracket H plus bracket. The bracket means concentration and molarity. I have pH. So on my set of equations, I'm looking for an equation that has pH equal, H plus ion concentration equal, and then on the right-hand side of the equal sign, I see something about pH. Sure enough, I see one that says that the H plus ion concentration is 10 raised to the negative pH power. That's because the pH is the log and the log is related to the exponent. So I'm going to type into my calculator 10 raised to the negative 3.6 power. You'll find the 10 raised to the power usually over the log button because it's the inverse of the log. A lot of times the second button with the log button will get you 10 raised to the x power. Make sure to include that negative sign, it will change your answer. And I get 2.51 times 10 to the negative 4. Once again, I know that the pH is related to the exponent. The pH is 3, the exponent is negative 4. So I'm thinking, okay, 3 is within 1 of 4. And so this looks like the math has worked out right on this problem. And what if we were asked to find the concentration of OH minus ions in a pH 3.6 solution? This is a two-step problem. This is in logs, because I see the P in front, so it's in the log system. This is concentration, but it's not of H, it's of OH minus ions. I need to do it in 2 steps. I know I need OH minus concentration, so I can look at some of my equations. I've got OH minus is equal to 10 to the negative POH, but I don't have POH, I have pH. I also have OH minus equals 1 times 10 to the negative 14 divided by the concentration of H plus ion. So somehow I need to get from pH either to POH or from pH to H plus ion concentration. Well, from the previous problem, we know that we already have, if we take 10 and raise it to the power negative 3.6, that will get us the H plus ion concentration. (2.51 times 10 to the negative 4. And if I remember my exponents, when I have an exponent on the top and an exponent on the bottom, I should be subtracting. So negative 14 minus a negative 4 would be negative 14 plus 4, should be somewhere around negative 10 as an exponent. 1 e negative 14 divided by 2.51 e negative 4, and I get 3.98 times 10 to the negative 11 molarity. So my math looks to be good. I'm happy with this value. Another strategy would be able to go from pH to POH, and then from POH, I could raise 10 to the negative POH power would be the concentration of OH minus ions. I can do this by remembering the fact that pH plus POH always sum to the number 14. So 3.6 plus POH is equal to 14. So if I subtract 3.6 from 14, I get POH is equal to 10.4. Now I could take that number and plug it into this. 10 to the negative 10.4 power equals 3.98 times 10 to the negative 11. I hope it's not surprising that I get the same answer. A lot of times you'll simply be asked something along these lines, given a certain H plus concentration, tell me what the OH minus concentration is. I always get that by taking 1 times 10 to the negative 14, divided by the concentration I do know, it'll get me the concentration of the other ion. H plus ion and OH minus ion are always related. They always multiply together to get me 1 times 10 to the negative 14. There you go.